Good morning everyone. Welcome to Gurdwara session. We are into multi-threading, advanced topic. And in previous session, we have seen reentrant law, that is a class. And based on that, we have understand what is reentrant class, what is the method available. Okay. And based on that, we have seen one program. So basically, reentrant method, we have seen this program with the help of this program, we have seen. So in previous program, what we have seen, this is a test class, which is extending thread class. So we are defining thread. Okay. This is one constructor with parameter, and we are sorry. There are three class, right? Yeah. So this is test class extending thread, and it is having run method. This run method is called by whom? Which method? Start method. Inside run method, we are calling one get balance method. So this method will be called get balance when this get balance method will be called by a run method. A run method will be called by which method? You know, right? Start method. Start method are called by threads. So these are the threads. There are two threads. This is thread 1 and this is thread 2. So thread 1, thread 2 call these methods. So earlier we know this synchronized keyword concept, and to overcome this synchronized, because there are a lot of disadvantage of synchronized keyword. So what we are having, we are using instead of that reentrant class. Okay, now try to observe. Then we will go with one more program. So let me cross this. Let me comment this line. We are using reentrant class. Instead of synchronized keyword here, we are using what? L.lock and L.unlock. Now try to observe. Let me comment this line. This will be like a normal call, and we don't know which output will come. Let me run this program. Run a Java application. See, not able. Amit, Mangesh. These are the random output, right? These are the random output. Let me uncomment this lock method and unlock method. Now let me run the program. This we have seen yesterday in previous session. See, Amit. First thread Amit will be done. Then Mangesh started. Mangesh, right? Then it will be done. So what we are doing, we are locking on one thread. It performing its complete operation. Then we are unlocking. The moment we are unlocking, Mangesh thread is working on this object, and it is trying to perform some operation. If we are not releasing unlock, then what will happen? See, it will be in continuously waiting state. Run as Java application. Only Amit thread will work, and Mangesh thread will be in waiting state. It will be never ending because we did not release the object. So locking the object and release the object is in our hand. See, it is in start still running mode, but we did not get Mangesh output here, right? Okay. Now, the moment I will unlock this, then object will be locked from thread 1, and then we get the after Amit thread, Mangesh thread will be there. Okay. See, Mangesh thread is running. This we have seen previous session. Now, guys, now try to observe. Now, retrend, we have one method called try with lock, right? Try with lock, right? We know lock object, we call lock method and in unlock method. Now, we want some logical thing now, right? Now we have seen instead of synchronous keyword how to use reentrant and lock unlock method. Now we will want to do some performance. If there is a lock, there is a lock. Okay. If there is a lock, do something. If there is no lock, do something. We don't want waiting period to waste our time. That's why try.lock method is there. Now we will see this program of try to observe. Now try to observe. Okay. Come here. We will keep this class as it is. There are two threads. Okay. Thread 1, thread 2. Perfectly fine. Okay. And yeah, this is fine. Now come here. Come here. We have to use test class because we are using in main. Which class we are using? This class. As it we have defined the thread, right? Now I'm changing this logic now. Little different. Okay. Now I will create reentrant lock RL equal to new reentrant lock. ठीक है? Control Shift O. ठीक है. Now extend three word, that is fine. Now I am using one variable. And constructor here. Alt Shift S O. ठीक है? Okay, one second, guys. Let me create as a static this one. Now this is static. Why is static? I will tell you. Now string. I'm using one variable. Alt Shift S O. Generate. ठीक है? This is a constructor. ठीक है? This is a constructor with the variable. Now only two class we are using. Try to observe here. Okay. I change this constructor so only one parameter is expected according to this program. That is, let me call as first thread, and this is string name, and let me give this. You know, right? Why error in this line? Because I changed the constructor. Only in test class, only one variable is expecting, that is one string. Okay. Only two program. One is on right side, one is on left side. Now try to observe. Now try to observe here. To call this start method, we should require run method, right? So let me take one run method also. Otherwise, superclass run method will don't have any output, right? So run method is required. Now run method is also there. Run method is also there, right? Run method will be called by start method. Start method will be called by thread T1 and T2. Okay. Now what is our logic? Try lock method. If and else we will use now. If some condition do something, then we have else do something. If lock is there, do something. If lock is not there, do something. Okay. Now what is my lock? Reentrant RL, right? Okay. Now try to observe. RL dot lock. RL dot lock. RL dot try lock. Sorry, try lock. Try lock. Okay. Now try to. If there is a lock, it will do something, and otherwise it will do something. Okay. Now try to observe. I want to do something. Some I want to print something. So let me print some statement here. System dot out dot println. System dot out dot println. I'm trying to print something in this block, and then I will try to print something in this block. How to format? Select all. Select all. Control Shift F. Okay. Now try to observe. I want to know what is the current thread name. So let me print some thread name also. Which thread is going to work? Which thread is going to thread dot current thread. Thread dot current thread. Can I get the name of the thread? Get name. Get name. Get name. Okay. Means what we are printing? Whatever the thread will work, that thread is going to print something, right? Its name and its out result. Let me use this in else block also. paste here. Format the control shift F. Okay. Now this is only what printing. Okay. Now try to observe, guys. I am running this program. Thread 1, thread 0. Right? What is the output? Thread 1 and thread 0. Okay. Now let me do some slip command. If okay, let me do the slip for some time. I am passing some time. Let me pass some 2 milliseconds. You know, when we use slip method, it will ask for try catch or so I am using now this statement. Okay. Now try to observe. I can use here unlock. Cache block is done. I am releasing this lock here. Try to observe. What is the lock? RL dot unlock. RL dot unlock. Now it is terminated again. Let me. Okay. Now let me give some naming convention here so that we get proper output. Get the lock. Get lock and save operations. Here some statement unable to get lock. Alternate operation. Now try to observe. This is our run method. This is our try lock. This is our sysout statement. We are asking thread to sleep. Okay. Now what we are doing? We are doing unlock. If 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 get lock to do this. If unable to get lock, then do this. Okay. Now let me run again. See, guys, our both the thread are running fine, right? Are you getting? Try with lock. At the same time, I am using some sleep mode also, but at the parallel some operation is running. Again, try to observe what I am trying to do. This is our method. These are the t1 dot t2 dot start thread. It is going to start the call the run method. Both the thread. Generally, I am using what sleep. It means what? It should sleep na for 2 seconds, right? Let for 10 seconds also. 10 seconds. Are we? Is the both the thread working for 10 seconds? No, right? Immediate output we are getting. Immediate. No waiting period. Are you getting? No waiting period is there. No waiting period. Now try to observe. Waiting period. You will feel. I will comment this line. I will. If else I am commenting now. Now try to observe. There is no if else. There is no try. There is no unlock. Okay. Now only run method. What happened here? One second. T1 dot start. T2 dot start. See, waiting period 10 seconds, right? Observe, guys. I am running again one more time. Observe. First thread printing to state two statement. Now it will wait for 10 seconds. Now then observe. After that, two threads is printing this statement. After 10 seconds, we are getting this output, right? After 10 seconds. Thread 0 get lock and both the statement. It is printed by first statement. Okay? Thread 2 is then sleep mode. Try to observe. this line, very important. Thread 1 printing this line. After this, thread 1 got sleep. T1 is sleeping. Means T2 will come here. This line is printed. After that, T2 will reach here. It will sleep. So that's why two lines are printed by thread 1 and thread 2. After thread 2 sleep, thread T1 activate. T1 is printing this. So this line is printing after 10 seconds. Okay. And then its operation done. Then T2 is printing this line. This is what waiting period performance operate 10-second delay, right? Between these two line and these two line, there are delay of 10 seconds na. This is normal multi-threading. Now I don't want waiting time. So what I can do? What I can do? Clear the drawing. I need to use try block. If else 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 block. If else block. If lock is there, fine. Do this thing by that time. Don't wait. Now let me run the program. Save this. Run the program. Output done, right? Now try to observe. Why guys, what happened? Both are done, right? Now try to observe what is happening here. T1 is coming here. Means some thread is coming here. Any thread, right? Try to observe. And it is checking. Right? Unable to get the lock on operation. So what is printing? Some safe operation, right? And both safe operation and alternate operation, both are running, right? Now, so this line is printed, alternate option, because we don't know which is going to print. Again, then what happened in this part? Threads are sleeping also, right? No problem. But other thread is working on this line. One thread is printing this line, one thread is printing this line. Hope you are good. You have any difficulty to understand this? You can ping in the chat as well. Did you understand the program or any difficulty? So this is the behavior of try and lock. Okay, what we are doing, we are unlocking we are releasing after some operation. Then this is what happening. This is try lock. RL is nothing but what? Reentrant class. Common object. Why I am keeping static? One object will be common for this both the thread. That's why. So RL.try lock. What is happening? It is checking whether lock is there or not. If lock is there, don't wait. Execute this program. Alternate program. So this line, one thread is printing this one. See, thread 1 unable to get the lock of that's why alternate operation. This line is printing. In thread 1, there are two threads, thread 0 and thread 1. Thread 1 did not get the lock on first object. So it is coming here and printing this one. And after some time, what happened? Thread 0 get lock and save operation. This is called save operation. Right? Now, hope you are good. Okay? One second. Okay. Now, guys, the next concept is thread pool. Thread pools. What is thread pool? Now try to observe. We have to create thread one by one, right? In this program, what we are observing, try to observe. Thread 1, then thread 2, right? We have to create thread by our own, right? So creating a new thread, creating a new thread for a new job, for every new job, for every new job, for every new job leads to create performance issue, performance issue, ठीक है? And memory problem. We can say memory problem also because we are creating so many objects ना, memory problem. ठीक है ना? This is the problem with this traditional creating an objects. Like more objects means what? Unnecessary creating more object will memory issue, more memory consumption, slow performance. This is what two line. In project there may be more objects now. So that's why to avoid this problem, we have thread pool concept. We have to overcome this problem. To overcome this problem, we have thread pool concept. We have thread pool concept. Thread pool concept. Okay. Now, so what is this thread pool now? What is its definition? Thread pool. Thread pool is a pool of. It is a pool of. You know swimming pool, right? It is a pool. Similarly, it is a pool of already created threads to run the job. To run the job. Thread pool is what? Already there are pools. Pools means swimming pool. 10 people are swimming. 20 people are swimming like that. Pool means there are already a pool where already we are having so many threads are there. This is introduced in Java 1.5 version, and this is nothing but executor framework. This concept is nothing but executor framework. Executor framework. If people ask you in interview, do you know what is executor framework? So you can explain, yes, I know executor framework. Thread pool framework is also known as executor framework. Hope you are understanding. Okay? If somebody is asking what is framework, executor framework, right? You can explain this thing. Okay? Now. Okay? How to create a thread pool? Observe. So executor service. ES na you can give variable name equal to what? Mm, executor, executors, executors dot new fixed thread pool, and you can pass the number of the. Here you have to pass the number. Here you have to pass the number of thread pool you want. Okay? That is dependent on it's our choice. How much thread we want, we can define here. Okay? Now, after this ES variable, which is nothing but execute variable, after this we need to submit a job. There is a method submit, and here we need to pass a job. This two line is very important. And after our work is done, what we need to do? We need to make this serve as a down. ES dot shutdown. Once the work is done, shut down. That is simple three-line statement is there. This three line will help us to understand this thread pool executor framework. Okay? We will see programmatically now. Now, come here in our program. Now, these are the two classes. Let me rename this for executor program. Let me give this program to you also. Before this, let me take the screenshot and send this program to you first so that you can practice it for try catch. Okay, one second. First, let me give this program. This is first part of trial. ठीक है? I will save this program. I will share it to you. Okay. So now I am deleting this program. Save this and push it to. And this is executor demo. Let me give the name. Let me remove this program. Both are empty program now. Okay. Now try to observe. I am changing the name. Executor demo. Executor. Rename the file. Or here we have test class. Okay. To run this program. Okay. Now, in this executor demo, only we are going to run the program. So not much required here. Mud code here. Instead of thread, can I use implement runnable? Let me use implement runnable. Implement runnable. Control Shift O. Implements runnable. So automatically it is overwriters run method, right? See, at unimplemented method. Run method is coming from implement interface. Sorry, runnable interface. Okay. So here we will write our logic, right, to run the program. Okay. Now, let me take some variable. Let me take some variable string name. I am taking some string name. Okay. And yeah, one test constructor. So Alt Shift S O generate. So this is the constructor generated for this, which is expecting some name. Okay. And here I am having one run method. In this run method, can we have sleep method? Sysout statement. Let me system dot out dot print ln. Okay. This is our sysout statement. Okay. After sysout statement, let me have some thread dot sleep so that if there are two threads, one thread will give a chance to another thread. 5000 second I am giving. Then it is expecting what? Try catch block. Perfectly fine. Okay. One sysout statement here, and I am keeping one sysout statement after the catch block. Okay. Now what I will give here. Okay. Now try to observe. Format this. Try to observe. This is our run method called by whom? Till now we are giving what t dot start, t dot something like. Now that is not required. In this previous program, what we required? This t dot start, right? This t dot start is required, right? Now try to observe. That is not required here. Now observe here, guys. Let me give some sysout statement meaningful so that we can differentiate what our outputs. ठीक है? This output is due to which thread? I am concatenating thread dot current thread dot get name. So name will be printed, and which thread is going to print? That is going to print here. ठीक है? Now let me give here also what is the name. Some name I am going to pass from main method. ठीक है? Thread completed. Which thread get completed? Let me print that name. Thread dot current thread dot get name. ठीक है? Now try to observe. This is our run method. Run method is going to print something which is called by some threads. We did not define yet thread, right? Only test class is implementing runnable. Okay, defining the thread, calling this run method. Now come here to our program. This is our main method, right? This is our main method. Now I am giving some more work to this class. Like for example, I can create one array also, right? But before that, let me create some test class object. Test t equal to what? New test. T test equal to new test. But it is expecting some string, right? Constructor is required string. So I am giving some name Amit. Okay, now try to observe. Now my executor code. What is my executor code? Copy this, copy paste. Copy this line, 3 line, copy this 3 line, paste here. Did I use anywhere t dot start? No, right? Control Shift O, perfectly fine. Here I need to define the thread. How many thread I want? 1, 2, 3, 4, 5, 6. Let me go with one thread. I am giving, hey, executor thread pool. I want only one thread. Then what job you want? It is asking. Just give me the job. I will do for you. I am giving T. I am passing T here. After this job is done, it will get shut down. Let me run this program. Save this program. One thread. Done, right? There is only one thread 1, perfectly fine. This output is run. There is nothing required. We are doing this program on left side so many times. But who is doing right now? Did I create a t dot start this time? Did I started using t dot start like this? No. We are using executor framework. I am giving directly how many thread I want. One thread to perform this job. Did I call t dot start? No, I am giving submit. After this job is done, this service is shut down. Let me increase 2 thread. Can I give more thread? I want more thread. In the pool, I am defining more thread. Now let me run the program. Observe the output. Output is due to thread 1. Okay? Amit thread completed thread 1. Okay? What happened? Okay, guys, there is only one job, na? There is one job, right? There is only one job. Let me create multiple job. Can I create multiple job? How I can create multiple job? Let me create one array of job. Let me create some array of job. Now try to observe. Let me create some array of job. How I can create this new test, Amit? Let me remove this line. Now try to observe. This new Amit, I am keeping here in array. I can keep an inside array, right? Now, this is comma. I am creating multiple object in an array. 3 objects I am keeping. ठीक है? Amit, Mangesh, and SRK. These are the 3 names. Now I need to pass somewhere, na? I need to pass. Let me give semicolon, and I need to pass where equal to in array. Which type of array it is? Test array. Test array. Test array. Test array. Test array. Okay. Now try to observe. Now this array is having more than one object. One is for Amit, Mangesh, and SRK. I want this array to be completed by this thread group. es.test array. Okay. Sorry. This is array, right? How many objects are there? There are 3 objects. In array, n number of objects will be there. We cannot pass directly. We need to take for loop. For loop, right? What is for loop? We have to apply on this array. First, for example, in your from database, you are getting 100 records, 100 objects in one variable. It is this variable is storing this 3 objects, 300 objects, 3000 objects. That is not our problem. But when we have to perform something on this, we need to iterate it, right? How we can do that? For loop. For loop. What is the array? I want to get one object in a loop. Take this object inside there. What is the type of this array? What is the type of array? Some variable X I am taking. What is the type of array? Test. Now, what one by one, Amit loop will come, then Mangesh loop will come, then SRK loop will come. That will be holding X. That will be holding X. And then I can submit to his executor framework. Take this X one by one and do perform the operation. Once this loop is done, then after your job, close this or shut down this, your framework. Let me run this program. Now you are observing the output, right? Thread 1, thread 2. See, read this thread 1, thread 2, thread 1, thread 2, thread 1, right? So now try to observe what I am giving. See, Amit, this is due to thread 1. Amit, this is due to thread 1. Then Mangesh, this output is thread 2. Mangesh, this is thread 2. SRK, thread 1. SRK, thread 1, right? Now try to observe. Can I increase the thread? Can I increase the thread? Let me give only one thread now. I am giving this time one thread. Now let me run this program. Only one thread is there. Only one thread will complete all the tasks. Amit, Mangesh, SRK. See, one thread is doing only all the job. Amit, Mangesh, SRK. Can I increase now? Now observe. Everywhere what? Previously thread 1, thread 1, thread 1, thread 1, thread 1. Now I increase 2 thread. I'm increasing, giving 2 threads to ThreadPool and asking all the threads should work together. So now see, Amit is working on thread 1, Mangesh, second thread is working on Mangesh. Then Mangesh thread 2 sub. We don't know output, but see, for 2 threads are working on run object. Run method. to perform some operation. See, thread 1, thread 2, thread 2, thread 2, thread 1, thread 2, right? Now, can I increase the thread? Save this. Let me increase thread to 3. Thread 1, 2, 3 done. Now thread 1, 2, 3 done. Right? There are 3 threads. 3 threads working on this. Can I increase this thread? Let me increase 5 thread. Now 5 thread will be there. 5 thread will do the job. One second. What happened? See, 1, 2, 3, 4, thread 4. 1, 2, 3, 4. Then, hope you are understanding. Now, who is doing? Are we creating the threads? We are not creating the threads. We are asking ThreadPool. I am asking you to take care of 4 threads. Then what happen? We are just this ThreadPool is having 4 threads. This is normal our array. In array, what we are doing? Some array we are creating. Like whenever array Amit is there, in first iteration, in test array, it will look first iteration. What will take? Amit. Okay. Amit is submitted. Amit is submitted. Amit is submitted. Then in say next iteration, what will happen? Mangesh. Mangesh will be submitted. Then SRK will be submitted. Then Rakesh will be submitted. Then Dhawan will be submitted. And every time this run method will be called. Run method will be called. See, we are submitting, right? And that time, whatever the name is coming, like for Amit, when Amit thread, when it is looking for Amit array. So then Amit, which thread is performed? See, Amit is printing. This output is due to which thread? We try to understand by printing this line. Thread dot current thread and get name. So what is the current thread? Let me give some space also here. Some naming convention. Now let me run the program. Now try to observe this. I am pass whatever loop is this is running. See, Mangesh. This output is due to pool 1. All thread belong to only one pool, guys. Right? Pool 1, pool 1, pool 1, pool 1, pool 1. All threads belong to one pool only. Pool 1 now. Okay? So now see. Thread 2 belong to pool 1. Thread 1 belong to pool 1. Thread 3 belong to pool 1. Thread 4 belong to pool 1. So now thread 2, when Mangesh, this output is due to which thread? Pool 1, thread 2. This thread 2, but this belong to pool 1. After that, what happened? Amit. When the Amit is running, which thread we don't know. So Amit, this thread is due to pool 1. Which thread? Thread 1. Thread 3. Thread 4. Are you getting? Okay, now try to observe. So after this operation, this all this job is done, this get shut down. ठीक है now. ठीक है now. Final topic of multi-threading is, guys, callable and future. Very important final topic, callable and future. Callable and future. Something we are doing and we did not get the output, then we will think something is not good, right? We are not getting output. So that is related to this callable and future. Okay. Now try to observe. In case of runnable, in case of runnable job thread, won't return anything, won't return anything, won't return anything. Okay. But if we want some output to get as a return, after execution, we should go for callable. We should go for callable. We should go for callable. Try to observe, guys. Very important. Here in the program, what I am using? Implement runnable. Runnable run method is giving any output, guys? Tell me first. No, right? Runnable run method is not giving any output. So if you are doing any work also, how you will get the output? It is a return type is void. Are you getting? If the return type is void, you are not going to get any output from run method. So instead of runnable method, instead of runnable interface, if I can use callable interface, advanced topic. Instead of run method, can I use call method? Can I use call method? Then in that situation, we can get the output. We can get the output. See, anyhow, we are achieving multi-threading. See, day by day, advanced thing is coming now. Now we are not creating any threads. We are not calling any start method. In this previous program, we are implementing runnable run method, which out of thread and runnable, which is better option now? Runnable. We learned that runnable because I can extend some other class also, right? If I want to make this extend serializable, tomorrow serializable, that option is available with me. Serializable. I can extend this. Extends. Serializable, right? Means I can implement do and I can extend. There is some option available. But if I am implementing runnable, I am achieving multi-threading. I am extending this. I am able to extend any class. That inheritance is available. But tell me, if implement runnable I am doing, then run method is available. But run method is giving output. No, right? Some logic we have to do. That's it. But no output we can expect. That is a disadvantage of implement runnable. Now, callable interface is there, which is having call method, which will give the object now. Which will give the object now. Which will give the object now. Now try to observe how. These are the final and important. People will ask this also in the interview. Okay? And these are important to understand as well. So now, callable. Callable. It is an interface, first of all. It is an interface. It is an interface. Okay? Which contain only one method, which contain only one method. What is the name of method? Call method. Call method. Tell me guys, simple basics, common sense. Call method. Now tell me what is the syntax of method M1? This is method, right? This is method thing. If any no output is then void. String output, then we can keep a return type string. We required employee return type. We can keep like this. We want return type int, then we can keep. But if we keep object, it means this method can return anything na that can be held by object, right? That is the intention. That's why the intentionally the call method return type is this is your call method. Okay, this is your call method, and it is return type is object, which is not here, right? Which is not here in run method, which is not in run method, right? ठीक है. Hope you are good with this. Now tell me. Now, then we have title, callable, and future. ठीक है. So we understand callable. ठीक है. Now we are able to give some return type as an object. ठीक है. Now next point. Next point. If we submit if we submit if we submit if we submit a callable object. Now guys, observe what we are passing here to executor framework. Some task we are giving na, some task we are submitting something to executor framework. Same way, if we submit a callable object to executor framework, executor framework, right? To return an object, to return an object. Okay. Then 1 second. We submit a callable object to executor framework. Then it will return an object of type java dot util dot concurrent dot future. Okay. If we submit a callable object, for example, whatever object we are passing to executor framework, some output we are going to return na, it will be of object of which type? Future object. What is future object? Now the future object can be used to get some results from callable job. This is our final topic, and one program is required to demonstrate this. Then you will able to understand. But you are understanding by seeing, right? This program. Runnable method don't give any output. Runnable interface don't give any output. Runnable interface, run method don't give any output. So if you do anything, if you don't expect the output, go with runnable. But if you want some multi-threading concept, that time we should go with callable. And callable interface have call method which returns object. And inside this object, if some output is there, then we can use the object results by using future. Okay, that is our tomorrow program, and tomorrow we will start most probably collection. Okay, we will understand this by program, and then we will start collections. Okay, I'm stopping my screen share, and if you are having any doubt, you can talk to me now.